Welcome to the best way to clean your AC unit and coils.
Yeah, thanks for having me.
Of course. So, right now, sitting out in your backyard, or maybe tucked alongside your house, there is a machine that is likely suffocating.
Literally suffocating me.
Right. It is trying to breathe through like a microscopic straw. And because of that localized asphyxiation, it's quietly siphoning hundreds of dollars out of your wallet every single summer.
It really is. I mean, it's an invisible drain on your finances.
Exactly. So our mission for today's deep dive is to explore a masterclass in reviving that exact machine. We are breaking down a highly specific, practical process from the YouTube channel, Clean That Up.
Which is a fantastic resource, by the way.
Oh, totally. They offer this brilliant blueprint for restoring an inefficient, money-draining air conditioning unit right in your own yard.
Okay, let's unpack this. Because we are looking at this not merely as a yard chore, but as this fascinating intersection of, home economics, fluid dynamics, and mechanical efficiency.
Right. It's so much more than just spraying water on a box. Yeah. When you notice your house just isn't getting cool, or the vents are blowing lukewarm air, the immediate psychological reaction is just sheer panic.
Oh, for sure. You immediately assume the worst.
You assume the compressor is dead, or the Freon has leaked out into the atmosphere, or you are facing a massive replacement bill. But the data in our source material today suggests the primary culprit is often far less catastrophic, though just as insidious.
Heavily clogged condenser coils.
Yes. Heavily clogged condenser coils. So why is that such a big deal?
Well, the physics of how that unit operates rely entirely on unobstructed airflow. I mean, an air conditioning system does not actually create cold air in the way we typically imagine.
Right, it's not like an ice maker.
Exactly. It operates on the principles of thermodynamics, specifically heat transfer. So that massive box sitting outside your home is a condenser. Its sole job is to take the ambient heat that was absorbed from inside your house, move it through copper tubing via compressed refrigerant.
They have to push it outside, right?
Right, yeah. Radiate that heat out into the surrounding outdoor environment. And to facilitate that transfer, it uses thousands of ultra-thin aluminum fins.
Okay, those are the little metal grates you see on the sides.
Yep. Those drastically increase the surface area for heat to dissipate, but they only work if massive volumes of outside air can be pulled across them.
Ah, I see.
So when those fins are coated in a matrix of dirt, pollen, oxidized leaves, and airborne lipids, that matrix acts as a thermal blanket.
A thermal blanket. Wow, that is a great way to visualize it.
Yeah, it literally traps the heat. The fan has to work twice as hard to pull half as much air, and the compressor runs hotter and longer.
So you aren't just losing comfort. You are paying a severe thermodynamic penalty on your monthly energy bill.
Exactly. You're paying for it to struggle.
That thermal blanket concept really reflames the whole issue for me. It isn't a cosmetic problem, it's a mechanical crisis.
It really is.
And to fix it, we are going to walk you through the precise method to strip that blanket away. But before we get anywhere near the water hose or the chemical cleaners, we have to navigate a major hazard.
Oh, absolutely. This is critical.
Yeah. The very first step of this entire process operates entirely in the realm of life safety. The foundational rule of AC maintenance is isolating the power.
Right, because we were talking about interacting with a 240-volt electrical appliance.
While using highly conductive liquids.
Exactly. A really bad combination if you're not careful.
Yeah, the source is unequivocal here. You must physically disconnect the power at the exterior breaker box before any cleaning begins.
And the rationale here goes beyond just, flipping a switch indoors on your main panel.
Right, you have to go outside.
Yeah, the creator directs us to the physical disconnect box. It's often this gray, weatherproof housing mounted on the siding right next to the condenser.
I know exactly the one.
Inside that box is a pull-out block. You have to physically grip the handle and yank the entire block out of the circuit.
And that action, it just severs the 240-volt supply lines entirely.
Precisely.
Yeah.
The reason you don't just rely on the main breaker panel inside your garage is proximity and control.
Right, because someone inside could just flip it back on.
Exactly. When you remove the block at the unit, you have visual, tactile confirmation that the circuit is dead right there at the point of contact.
The engineering of that pull-out block is actually quite clever, too. The creator points out that when the block is plugged in and bridging the connection, the word on is stamped on the handle.
Right.
But when you pull it out and flip it upside down, it reads, oh, off.
Yeah, and you can reinsert it in that inverted position, and it will sit securely in a housing without completing the electrical circuit.
It's a physical failsafe, which is brilliant.
It is, but the creator actually prefers a slightly different method.
Oh. What does he do?
Instead of plugging it back in upside down, he sets the pull block right on top of the disconnect box.
Just rests it up there.
Yeah. His rationale is that keeping it entirely out of the slot, but right in his line of sight, serves as this unmissable reminder to restore the power when the job is done.
Oh, I see. If we connect this to the bigger picture, we run into a fascinating tension between cognitive aids and environmental hazards, right?
Exactly. Keeping the block in your line of sight is excellent for memory retention.
Yeah, it prevents that classic mistake of finishing the job, going inside, and wondering why the AC won't turn on.
Right. But the creator immediately introduces a critical modifier to this trick, which is the splash zone.
The splash zone.
You have to assess the spatial relationship between your unit and that box. If they're within a few feet of each other, setting the block on top of the box exposes it to errant spray when you start using the hose.
And water and those heavy-duty copper prongs do not mix.
Not at all. If you're in the splash zone, the protocol changes. You must physically remove that block from the immediate environment.
So put it in your pocket, carry it into the garage, or set it on a distant patio table.
Exactly. Get it out of there.
Uh,
And furthermore, the source emphasizes closing the door of the empty disconnect box securely.
Oh, to protect the internal wiring from the incoming water.
Yes, exactly.
You know, it closely mirrors the lockout-tagout protocols used in industrial manufacturing.
Well, that's a great comparison.
Right. If a technician is working on a massive hydraulic press, they don't just ask someone to flip the power off. They apply a physical padlock to the breaker and put the only key in their pocket.
Right.
That physical barrier eliminates the variable of human error. No one can accidentally re-energize the system while you're inside the machine.
Taking the AC block and putting it in your pocket is literally the residential equivalent of lockout-tagout. You maintain total custody of the power source.
Exactly. But observing human behavior, especially in weekend DIY projects, there is a strong psychological pull to skip this kind of prep work, isn't there?
Oh, huge. The urge to just grab the hose and start blasting the dirt away is incredibly high because that's where the visible, satisfying results are.
Yeah, the fun part. Is it common for people to jump straight to the water hose and skip the power disconnect out of excitement?
Oh, entirely common. That urge is rooted in hyperbolic discounting.
Hyperbolic discount.
Yeah, it basically means we value immediate, highly visible progress over the invisible assurance of safety. Dealing with stiff electrical boxes feels like bureaucratic overhead.
It delays the gratification of the task.
Exactly. But yielding to that impatience introduces catastrophic risk. Rushing past the isolation phase turns a standard 40-minute maintenance routine into a potential high-voltage incident.
Right, so the discipline required to manage the prep work is just as integral to the success of the project as the application of the cleaner.
Without a doubt.
Okay, so discipline sets the stage. The power is successfully isolated, the machine is dead.
Safe to proceed.
Now we transition into the physical disassembly and what we'll classify as the dry clean phase. To access the internal cavity, the top of the unit has to come off.
Right. And the source notes that because of the sheer variety of manufacturers, there isn't a single universal blueprint for this.
Yeah, generally you are looking at extracting about 8 or 9 screws that secure the top grill and fan housing to the side panels.
And the creator suggests a very pragmatic step here. If the geometry of your unit isn't immediately obvious, take 15 seconds to search your specific make and model online.
Just Google it. Yeah, it saves so much headache.
Because the critical phase begins the moment those screws are removed. That top grill is not just a passive lid.
No.
No, it is the structural support for the fan motor and the fan blades. When you lift it, you are lifting the entire primary moving mechanism of the system.
Oh, wow, that sounds delicate.
Very. That motor is tethered to the main chassis by a bundle of electrical wires. You have to lift the lid with mechanical empathy.
Mechanical empathy, I love that phrase.
You cannot yank it or set it down haphazardly. If you overextend that wiring harness, you risk pulling a connection loose from a terminal block or damaging the insulation.
Okay, so you have to be gentle.
The source advises carefully resting the lid on the edge of the unit, or better yet, having a second person to hold it securely, ensuring there is zero tension on those vital wires.
And while you're managing the weight of that motor and the tension of the wires, you have to be hyper aware of the fan blades protruding beneath it, right?
Oh, absolutely. The source issues a stark warning against using those blades as a makeshift handle to lift the assembly.
Which is so tempting.
It is. Or allowing the weight of the motor to rest on the blades when you set it down.
Why is that so dangerous?
Well, the engineering tolerances of those fan blades are surprisingly narrow, They are stamped from metal and then precisely balanced at the factory, often down to fractions of a gram, to account for rotational dynamics.
Ah, so they spin smoothly.
Right. If you grab a blade and inadvertently warp its pitch by even a millimeter or two, you disrupt that centripetal balance.
Just a millimeter.
That's all it takes.
Yeah.
When the system powers back on, that slight imbalance generates a microscopic wobble. And at several hundred revolutions per minute, that wobble translates into severe harmonic vibration.
Oh, so it'll get super loud and noisy.
It will generate an irritating hum, sure. But worse, that vibration travels straight down the drive shaft and begins grinding away at the motor bearings.
Oh, man. So a momentary lapse in care during disassembly can induce a slow, cascading mechanical failure over the next few months.
Exactly. You won't notice it immediately, but it's dying.
That is terrifying, and that mechanical fragility extends right down to the condenser coils themselves, too.
Yes, the fins.
We mentioned earlier that they are made of aluminum. To maximize the surface area for heat exchange, engineers make those fins incredibly thin.
Sometimes akin to the thickness of heavy-duty aluminum foil.
Yeah. The video highlights how easily they can be damaged. If you brush against them too hard with a tool or apply localized pressure, they will just fold over and flatten out.
And once they are flattened, they completely block the airflow through that section, which entirely defeats the purpose of the cleaning we're about to do.
Because the air can't get through the blanket anymore.
Right. It creates a localized dead zone in your heat exchanger. The air simply hits the flattened metal and deflects.
So the machine loses efficiency proportionally to the surface area you've accidentally crushed.
Exactly. So navigating the interior of this machine requires a great deal of deliberate, controlled movement.
Okay, so once that heavy lid is safely supported and you are looking down into the belly of the unit, you're usually met with what looks like a miniature forest floor.
Oh, yeah. It's wild what gets in there.
You'll find accumulations of dead leaves, pine needles, bark, and dirt that have been pulled through the top grill over the seasons.
And the intervention here is entirely dry. You take a standard shop vac and vacuum out all the loose debris resting on the bottom pan.
And here's where it gets really interesting, because the creator includes a moment of his own flawed execution in the video, which is incredibly illustrative.
Oh, I love that he left this in.
Me too. As he is scooping out handfuls of dry soil and debris, he tosses it onto the ground right at the base of the exterior coils.
Okay.
But he catches the mistake almost instantly, realizing the fundamental airflow mechanics of the machine he's working on.
Right, that realization underscores the true nature of the condenser. When it is active, the massive fan we discussed earlier acts as an impeller.
It pulls air in.
Violently. It creates a low-pressure zone inside the central cavity, which violently pulls ambient air inward through all four sides of the exterior fins.
So by discarding the extracted debris right at the base of those intake panels, he guaranteed that the moment the power was restored, the system would immediately ingest that exact same dirt.
Exactly. Lodging it deeply into the freshly cleaned aluminum fins.
It's the equivalent of sweeping a pile of sawdust directly into the intake side of a high-velocity fan. You are simply relocating the debris to the worst possible place.
You have to bag that dry waste or move it entirely away from the operational footprint of the unit.
And while addressing the base of the interior, the creator points out a structural feature that often goes unnoticed, which is the drainage ports.
Ah, yes. The weep holes.
What's their purpose?
Well, the floor pan of the condenser is designed to manage moisture. It is exposed to rain, melting snow, and its own internal condensation.
Right.
Along the bottom edge, there are small weep holes engineered to let that water escape. But over several seasons, the combination of decaying organic matter and fine dust creates this dense, clay-like sludge.
And that completely occludes those ports.
Yes. The strategic advice here is not to aggressively scrub them dry at this very moment, because you are about to introduce significant amounts of liquid into the chassis.
But you must mentally log their location.
Right. Before you close the unit back up, you have to verify those ports are unblocked.
Because if they remain sealed, the water you use during the rinse phase will pool.
Exactly. Creating a corrosive standing puddle that will slowly rust the base pan and potentially submerge the lower electrical connections.
Which is a nightmare. Everything has to have a clear pathway, whether it's air moving through the fins or water moving out of the base pan. Ensuring your environment functions efficiently is a theme that applies inside your house as much as outside. Speaking of getting things expertly cleaned and functioning at their peak, take a moment to visit KINDKEKE carpet cleaning on Google.
That's a really great point.
Yeah, just as your AC unit requires methodical, deep cleaning to breathe and perform, the carpets and upholstery in your living spaces act as massive environmental filters. They trap dust, airborne allergens, and daily particulate matter that a standard vacuum simply cannot extract. Having those fibers professionally serviced doesn't just restore the visual aesthetic of the room, it fundamentally improves the air quality and the environmental health of your home. For a truly professional refresh, remember to look up KINDKEKE carpet cleaning on Google.
Absolutely essential.
All right, so back to the unit. We've now cleared the physical obstructions. The power is secured, the lid is safely aside, and the dry leaves are gone.
But the fins are still coated in that microscopic layer of baked-on grime that the shop vac cannot touch.
Right. We have to change our methodology from mechanical removal to chemical breakdown. Which brings us to section 3, the chemistry of cleaning.
And the transition from dry mechanical cleaning to wet chemical cleaning requires very specific compounds.
Yeah, a simple blast of water isn't sufficient here, is it?
No, because the dirt bound to the condenser fins is rarely just dry dust. It is typically a complex matrix of airborne particulate matter bound together by lipids.
Lipids, like fats.
Yeah. Oils from lawnmower exhaust, resins from trees, and just general environmental smog.
Gross.
Very. And these substances are inherently hydrophobic, meaning they repel water.
So water just beads right off them.
Exactly. So the source material strongly advocates for a specialized foaming coil cleaner. The creator utilizes a brand called King, though the chemical principles apply across various professional-grade products.
And the application technique is highly specific, too. You take the aerosol can and apply the foam to the exterior face of the coils, but you strictly begin at the lowest point of the unit and methodically work your way upward.
Yes. Bottom to top.
I want to examine the logic of that bottom-up approach, because instinctively, when we clean almost anything, a window, a car, a shower door, we start at the top so the soap can run down, right? Letting gravity assist the process. Starting at the bottom and spraying upward seems counterintuitive. Why fight the pull of gravity?
It's a great question. The logic is deeply rooted in fluid dynamics and chemical concentration.
Okay, break that down for me.
If you apply the chemical to the top edge first, gravity will immediately pull the liquid down the face of the fins. As it descends, it coats the lower sections of the unit with a diluted wash of cleaner and loosened dirt.
Right, it gets all wet and muddy down there.
Exactly. So when you eventually aim your spray nozzle at those lower sections, the concentrated foam from your can hits a surface that is already saturated with this runoff.
Oh,
Yeah.
and that pre-existing moisture severely dilutes the active surfactants in the foam.
Yes, preventing them from achieving maximum adhesion and chemical breakdown. Furthermore, the lower quarter of the AC unit is universally the most heavily soiled area anyway.
Because it sits in the splash zone during heavy rainstorms, it intercepts the most lawn clippings, catches ground-level dust.
Exactly. By applying the foam to the dry, heavily soiled bottom sections first, you ensure the highest possible concentration of the chemical directly attacks the worst of the blockage.
And as you work upward, any runoff simply glides over areas that have already been treated.
You've got it.
That structural logic makes total sense. You preserve the potency of the chemical for the toughest zones, and that brings up the physical state of the cleaner itself. Why use a heavy foam instead of, like, a highly concentrated liquid degreaser in a standard trigger spray bottle?
What's fascinating here is the manipulation of surface tension.
Surface tension, okay.
The aluminum fins are arranged vertically. If you spray a standard low-viscosity liquid onto a vertical plane, it shears off almost instantly.
It just drips right off into the grass.
Exactly. It simply lacks the adhesion to cling to the metal long enough for the chemical reaction to occur.
Ah, and foam is engineered to overcome this.
By introducing air into the surfactant, it creates a three-dimensional matrix of bubbles. This matrix drastically increases the surface tension, allowing the active cleaning agents to cling tenaciously to the vertical fins.
It holds the chemistry directly against the lipid-bound dirt, defying gravity.
Right. And the source also emphasizes the delivery mechanism. You need an aerosol can with a straight, highly directional spray nozzle.
Avoiding the wide, misty fan sprays common in household cleaners, right?
Exactly.
Because the geometry of the fins dictates that requirement. Those fins aren't just a flat wall. They have depth. They form thousands of narrow, deep canyons of metal.
Right, and a wide, misty spray would simply coat the outermost edge of the fins, leaving the deep-seated blockages completely untouched.
The straight nozzle acts like a pressurized lance, driving the foam deep into the internal crevices.
And once that foam is driven into the depths of the fins, it begins to expand.
Like shaving cream.
Exactly like that.
Yeah.
That expansion creates a mechanical pushing action from the inside out, lifting the grime away from the aluminum surface.
Wow.
But to achieve that, you have to respect the most critical, yet frequently ignored, rule of chemical cleaning, which is dwell time.
Dwell time. The creator instructs us to set a timer for 10 to 15 minutes, right?
Yes. And during this period, you do absolutely nothing but watch the white foam slowly oxidize, turning a deep brown and gray as it breaks the molecular bonds of the dirt.
You just let it sit there.
Because the aluminum fins are so fragile, you cannot use stiff gristle brushes to scrub the dirt away. The chemistry is the direct substitute for physical abrasion.
So if you rush the dwell time, the bonds won't break and the dirt remains.
It is an exercise in restraint. The chemical needs time to break down those lipids and suspend the particulate matter.
And while the timer is ticking, the creator introduces a significant structural caveat that you really need to be aware of. We have been discussing the application of foam to the exterior wall of the unit, but he points out that while his personal machine is a single-wall unit, many systems are engineered as dual-wall units.
Yes, identifying whether you have a single or dual-wall system is critical to the efficacy of the clean.
How do you tell the difference?
When you look down into the open top of the unit, you need to observe the structure of the condenser coils. If you see one solid, continuous bank of fins separating the outside air from the central fan cavity, you have a single-wall unit.
Okay, that's straightforward.
However, if you look down and see an outer ring of fins, followed by an air gap of an inch or two, and then a second inner ring of fins nested inside, you have a dual-wall system.
Oh, wow. And the physical barrier of the outer wall means the foam you sprayed from the outside cannot possibly penetrate deeply enough to reach that interior ring?
Exactly. So your methodology has to be up to the architecture.
So if you spot that second inner wall, you have to lean over the top of the machine, reach down into the cavity, and apply the foaming cleaner directly to the inside face of that inner ring.
Yes, you have to surround the blockage with chemistry from both sides.
Okay, so you've identified your wall structure, applied the foam accordingly, and the 15-minute timer finally goes off. The foam has collapsed into a murky sludge. The chemical labor is complete.
Now we enter what might be the most counterintuitive yet mechanically vital phase of the project. Section 4, the inside-out rinse strategy and reassembly.
The transition back to water introduces strict parameters. The source is absolute on this point. You must use a standard garden hose with the nozzle set to a gentle fan or shower setting.
The use of a high-pressure washer is strictly forbidden.
Certainly.
The kinetic energy of a pressure washer will instantly fold the delicate aluminum fins flat, destroying the heat exchange capability of the unit and resulting in a catastrophic loss of efficiency.
You would essentially ruin the machine in 5 seconds.
Pretty much. The objective of the rinse is not to blast the dirt off the metal. The chemical foam has already severed the bonds holding the dirt in place.
Right, so the water merely serves as a gentle transport mechanism to flush the suspended sludge out of the structural matrix.
And the direction of that transport mechanism is the defining technique of the entire process.
Yes, the creator specifically demonstrates taking the hose, dropping it down into the central cavity of the open unit, and spraying the water from the inside, pointing outward through the fins.
The logic behind this inside-out backflush is brilliant.
Explain that for us.
It reverses the natural vector of force that deposited the dirt in the first place.
Oh, okay.
As we establish, the operational machine aggressively pulls air from the outside inward. Therefore, the pollen, dust, and organic matter are wedged tightly into the exterior face of the fins.
Right, so if you were to stand in your yard and spray the hose directly at the outside of the machine, the water pressure would push in the exact same direction the dirt originally traveled.
Exactly. You wouldn't be washing the blockage out, you would be ramming the debris deeper into the microscopic pinch points of the aluminum layers.
Oh, man. So by positioning the hose inside the central cavity and spraying outward, you are utilizing the water to push the debris back out the exact same pathway it entered.
Yes. You're lifting it out of the wedge rather than driving it deeper.
You're leveraging fluid dynamics to undo months of wind-driven compaction.
And you methodically work your way around the interior circumference, sweeping the gentle shower of water up and down the fins, watching the dark brown effluent cascade out onto the concrete pad or grass.
It's so satisfying to watch. You continue this deliberate process until the water running through the fins is entirely clear.
Right.
And while executing this step, standing over the open chassis and managing the hose, the creator shares an anecdote that is highly relatable to anyone doing yard work. He tilts the camera down to reveal his classic canvas Vans shoes, and they are just thoroughly soaked.
It's pretty funny, but it highlights the practical reality of the inside-out rinse.
Yeah, the water you are pushing horizontally through the fins is going to cascade down the exterior panels and pool around the base of the unit directly where you are standing.
Wearing permeable footwear is a guaranteed way to spend the rest of the project with wet feet. The pragmatic takeaway is to prepare your gear. Wear waterproof boots or dedicated yard shoes that can handle heavy runoff.
It's a small detail, but it speaks to the reality of the process. The
Okay.
creator also provides a realistic timeline for this endeavor. Yes.
Daisies. Factoring in the power isolation, the careful disassembly, the dry vacuuming, the chemical dwell time, and the meticulous inside-out rinse, he estimates the total duration at roughly 35 to 45 minutes.
That's really not bad. And he recommends integrating this into your home maintenance routine at least once a year.
Though he astutely notes that environmental variables may necessitate a more frequent schedule.
What kind of variables?
Well, if your property borders a dirt road, if you live in an arid region prone to heavy dust storms, or if your yard is heavily populated with cottonwood trees that shed dense fibrous seeds.
Oh, cottonwood fluff is brutal.
It is. In those situations, the unit is ingesting a significantly higher volume of particulate matter. In those high-stress environments, or if the unit runs continuously through intense heat waves, an annual cleaning might fall short.
Okay, so the machine's physical reality dictates the schedule. A biannual deep clean may be required to prevent the thermal blanket effect we discussed earlier.
Exactly.
So, as you finish the rinse and step back to assess the clean condenser, there's a subtle but vital psychological concept regarding home maintenance that the source brings up.
Yes, understanding the difference between dirt and physical degradation.
This is a crucial observation for anyone driven by a desire for perfection.
Oh, absolutely. The source points out that after you have meticulously backflushed the fins and the water runs clear, the machine may still not possess a factory-new appearance.
Right. He specifically focuses on the painted metal louvers or grills that protect the aluminum fins. The heavy, caked-on dirt is gone, but the metal beneath might show a dull gray or metallic silver hue shining through what was originally a solid matte black finish.
And the immediate instinct when you see that silver patching is to assume your cleaning chemistry failed, and that you are looking at a highly stubborn layer of calcified grime that needs aggressive scrubbing.
And acting on that instinct is where damage occurs, right?
Definitely. The creator intervenes to explain the reality of material science. This condenser lives its entire operational life exposed to harsh environmental extremes.
It absorbs intense ultraviolet radiation, endures hail, endures freezing rain, and withstands constant thermal cycling.
So that silver hue is not dirt. It is the literal oxidation and physical erosion of the factory paint layer over years of exposure.
Ironically, when the unit was heavily soiled, the uniform layer of dark grime effectively camouflaged this degradation, making the grill appear solid black.
Exactly. The cleaning process simply stripped away the illusion, revealing the authentic patina of wear and tear.
So the critical takeaway is to accept the physical reality of an aging machine. If you mistake oxidation for dirt and attack it with harsh abrasives, you will strip away the remaining protective coatings and accelerate the degradation.
It's an exercise in mechanical wabi-sabi.
Wabi-sabi, yeah. Finding satisfaction in the clean, efficient function of an older machine rather than chasing an impossible aesthetic perfection.
You have to let it be visually imperfect, knowing it is mechanically pristine.
The interior cavity is spotless, the fins are unobstructed, and the drainage ports at the base are clear. The final phase is reassembly.
Right. You carefully lift the heavy motor and lid assembly, once again managing the tension on the electrical harness and protecting the pitch of the fan blades.
You lower the lid into its seat on the chassis, taking care to ensure none of the internal wires are pinched under the heavy metal rim. And the creator offers a remarkably helpful geometric tip here regarding the screws.
Yes, when reattaching a large circular lid with multiple fastening points, it is easy to become frustrated trying to align all 8 or 9 screw holes simultaneously.
Because the metal casing often shifts slightly when the tension is released.
Exactly. The creator's advice is to ignore the overall alignment and focus entirely on perfectly seating just one single screw.
Just get one in.
Once that first point is securely threaded and anchored, the structural geometry of the lid is established, and the remaining holes will naturally pivot into proper alignment with minimal effort.
It eliminates the struggle of trying to force warped metal into place.
It really does.
So you secure the final screws, and the physical intervention is complete. So what does this all mean? We have taken a piece of complex, intimidating infrastructure and restored its optimal function through a logical, methodical process.
We have journeyed from a suffocating, inefficient machine bleeding money to a fully optimized thermodynamic heat exchanger.
We navigated the lethal potential of 240-volt circuits, respected the metallurgical fragility of aluminum fins, applied the surface tension principles of foaming surfactants, and utilized the fluid dynamics of an inside-out backflush.
But as it stands, the unit is still entirely dormant.
Right. The final act, the culmination of this meticulous 45-minute procedure, is returning to the disconnect box.
You retrieve the pull-out block from your pocket or the garage. Verify it is oriented with the on-stamp upright, and firmly seat it back into the high-voltage prongs, restoring the electrical flow.
The moment the thermostat calls for cooling and that condenser engages, you hear the compressor kick in with a deep, resonant hum, and you can physically feel the massive column of hot air being forcefully expelled straight up from the exhaust fan.
That thermal exhaust is the tangible proof of your success. It is the immediate, visceral reward for your discipline and attention to detail.
You are quite literally feeling the heat leaving your home with renewed efficiency.
It is the feeling of mechanical victory.
It totally is. We want to express our gratitude to the creator who provided this incredibly detailed methodology. The YouTube channel is called Clean That Up. In the video we reviewed, the host mentions they are rapidly approaching a massive milestone of 1 million subscribers.
Which is a clear reflection of how invaluable this type of clear, practical instruction is for homeowners.
Oh, undoubtedly. He also highlighted their dedicated community on Patreon, known as the Clean Squad. For those looking for even more structured guidance, they offer downloadable PDF cleaning guides that organize these complex weekend tasks into simple, step-by-step checklists.
We highly encourage you to explore their channel and utilize their resources.
Definitely.
And this raises an important question, one that expands the philosophy of this deep dive beyond the boundaries of the HVAC system.
What's that?
Well, we have spent this time examining how a single 45-minute application of targeted chemistry and fluid dynamics can drastically alter your home's energy consumption, enhance your daily comfort, and preserve the lifespan of a major mechanical asset.
Right.
If a compromised condenser coil can exact such a heavy thermodynamic and economic toll, we must consider what other hidden energy vampires are operating within your home right now.
Oh, wow. That's a great point.
What other vital appliances like refrigerator coils, dryer vents, water heater elements are quietly suffocating, steadily draining your resources, simply waiting for an hour of your time, a bit of specialized cleaning, and the discipline of routine maintenance?
That is an excellent thought to carry with you as you survey your own home's infrastructure. Every machine requires the space and clarity to function. Before we wrap up, a final reminder that while you optimize the exterior machinery of your home, the interior environment requires the same level of deep, methodical care.
Yes, exactly.
Don't forget to visit KINDKEKE Carpet Cleaning on Google for your interior cleaning needs, ensuring that your carpets and upholstery are as thoroughly refreshed and efficient as your newly restored air conditioning unit. Thank you for listening to the Best Way to Clean Your AC Unit and Coils podcast.